I thought I'd do a very brief sort of introduction of yourself. A brief because hopefully in talking, your journey and your work will sort of reveal itself. Does that sound okay?
Yes, no, absolutely. Well, I'll put myself in your hands. You're probably much more experienced than I am at this.
Okay. Yeah, so from what I can tell, you are somewhat, some might say, a master of many trades. You trained as a psychiatrist before pioneering methods in computational theoretical neuroscience through a welding of statistical physics, mathematics, biology, and psychology. The fruits of your career appear to be exemplified by the creation of statistical parametric mapping and dynamic causal modeling to, I guess you could say, prodigious forms of brain analysis, albeit I have the sense that dynamic causal modeling might have been extended beyond that. I might be wrong. And yet still some might say, though, that this stands in the background to your work on the free energy principle and its derivative, predictive coding, and predictive processing, which have been applied extensively to perception, but so now towards artificial intelligence and deep learning. So if I've mistaken or misrepresented you, please do let me know. But as I say, the questions I'm about to ask, I think will offer you the opportunity to clarify anything.
No, that was an excellent summary of the journey. Yeah.
Okay. Well, okay. Great. Well, so I wonder if you would be able to give a broad outline of the free energy principle, and if you're happy to, just to describe broadly again your intellectual journey and how you arrived at formulating the free energy principle.
Yeah. Perhaps it'd be simpler just to start with the journey. So
Okay.
I trained as a medic, but part of that training was always with an eye on the ultimate ambition to do what in those days would have been known as mathematical psychology. So I also did undergraduate physics, probability theory, and quantum theory. And then forgot it all completely for about a decade as I qualified as a psychiatrist ultimately. And then at that point, fortuitously, brain imaging, human brain mapping came to the fore as a new technology, literally to afford one a window on the working brain. And at that point, a lot of those early contributions to things like statistical parametric mapping and subsequently dynamic causal modeling were the result of a pressure to make sense of data. At the same time, me and many other people were drawn to deep questions about functional brain architectures and how we make sense of our sensory data. And it was a very small step, and I should say a step in which inherits from generations of work, and also guidance by people like Geoffrey Hinton, who was literally next door to where we were working in these early days. Questions about how the brain works, and just deploying exactly the same principles to how we were making the most sense of data to the brain as a little scientist making the most sense of its sensory data. So there was almost no real divide between the mathematical principles that we were deploying to model imaging neuroscience time series from the brain, and the model of how the brain was actually working in terms of modeling its sensory streams. And then that story led ultimately to things like the free energy principle, simply because the free energy is a quantity that you want to optimize if you want to make the most sense of your data. The key move that distinguishes, I think, the application of this principle of optimizing this free energy quantity when using it to understand how things like the brain works was to recognize that we, unlike a scientist faced with some data, are in charge moment to moment of gathering those data. However, if you think about it, of course, a good scientist spends most of her time actually designing experiments. So there's there is an active aspect. There's an active data gathering aspect to be a good scientist, in exactly the same way that if you and I and all our children are little scientists, they spend a lot of time acquiring the right kind of data that's going to enable them to make sense of their world, what's out there beyond their sensorium, what's causing their sensations. So the free energy principle was really just a statement that one could combine the principles of good sense making, good data analysis, with the principles that underwrite designing the right kinds of experiments, interrogating, acting upon the world, querying the world in the right way to reveal or disclose those data that are going to be most informative. So that's the, if you like, the narrative of my personal journey, discovery of ideas that have been around, I repeat, for probably centuries. So what is the free energy principle? It's just it can be described in many ways. I usually respond by saying there are sort of two routes to its description, a sort of a high road and a low road. The high road would be the kind of story you tell if you were a physicist, and I would say as a physicist, it is effectively a variational principle of least action. What does that mean? Well, it's just a way of prescribing the trajectories or the dynamics or the paths that things take. Particularly things that self-organize, things that are embedded in some environment, some milieu, and yet maintain some characteristic states, maintain their structure and their organization. So just by being able to maintain your structure and maintain yourself in some characteristic states, what the free energy principle does is say that, well, there is a description of these kinds of self-organizing things, and that description is mathematically almost identical to the principle of least action that would be used to describe the trajectory of a ball if I threw it into the air. So you can just write down the kinds of paths that I would take as a brain in exactly the same way I can write down the kind of paths a ball would take or a projectile would take if I threw it in a particular direction. And the key thing that inherits from that sort of physics formulation is that you can interpret these paths of least action, these paths of least effort, these most efficient paths as a process of inference. So that you can just look at effectively what is being minimized through these paths of least action and least effort. And the thing that's being minimized is exactly the same quantity that statisticians use to get the best models of their data, leading to this notion that everything, including you and me, or at least your brain and my brain, is in the game of effectively modeling the world out there, and in so doing, looks as if it is pursuing a path of least action, or to replace the action with the statistician's version of that action, trying to maximize the evidence for my models of the world. And that's sometimes neatly described as self-evidencing. So it looks as if anything that exists in the sense that I've just described is gathering data to acquire evidence for its own existence. And people like Jacob Howie describe this as self-evidencing. So a particular kind of self-organization that can be read in terms of this evidence gathering and sense making, sometimes described as the Bayesian mechanics, that is exactly the same as classical mechanics in ball throwing. And indeed, actually, you could also link it to both statistical mechanics and quantum mechanics. So that would be the high road. It's just a principle of least action, a variational principle of least action that, when deployed, allows you to simulate self-organization with this Bayesian twist that can be read as belief updating and sense making, a very basic or elemental kind of sentience. The low road tells the same story, but in a slightly more heuristic way, and that's calls upon the notion of something you've already mentioned, which is predictive processing. So, I mean, this story probably starts with Plato, comes through Kant and Helmholtz in the form of unconscious inference, and all the good psychology, of the kind proposed by people like Richard Gregory, sort of perception justice hypothesis testing, again with this statistical scientific aspect to it. And the idea here is that the brain is in the game of making the most sense of the world by trying to infer the causes of sensations. So the brain is literally a fantastic organ. It has these hypotheses or fantasies that are the best explanation for the sensory evidence at hand. And you may be asking, well, how does it sort of cope with a changing environment? Well, one way of getting the best explanation for the data is to try and predict what you would see if your fantasy was correct, and then compare those predictions against what you're actually measuring or sensing with your sense organs, with your sensory epithelia. And that comparison engenders a prediction error. And if you can explain away or minimize or resolve that prediction error, then you've got a good enough explanation. And this is just the, if you like, the self-evidencing that the physicist would be looking for, but now articulated in terms of a particular kind of predictive processing, namely predictive coding, that you're trying to update your beliefs, literally encoded by neuronal activity, in a way that eliminates any prediction errors. So that's where the predictive part comes in. It's basically me, as Andy Clark would say, in a very much a sort of inside-out kind of way, actively constructing explanations in the form of predictions at the sensory level that I can then test against the actual input in order to use the ensuing prediction errors to update my beliefs. And if you're a statistician, you call this Bayesian belief updating. And then you can write that down in terms of the maths or the dynamics, the neuronal dynamics that would be, if you like, implementing this kind of predictive coding. And it turns out to be exactly the same equations that the physicist would bring to the table, because these are exactly the paths of least action that would ensue by application of the free energy principle.
Yes, wonderful. Yeah, thank you for that. And following on from that, I have a question. So, I mean, my background's not in physics. So sometimes when I'm, particularly, I suppose, when I'm reading papers on the free energy principle, I can sometimes find myself somewhat confused, or just that I'm lacking certain knowledge. And so talking of the free energy principle, it states, from what I can gather, is that any random dynamical non-equilibrium system is what we're talking of, which is I guess you could say blanketed with a Markov blanket. Firstly, is that how you just, to talk of the free energy principle, or a system which is the free energy principle applies to, does it have to have those features? And also, having those features, does it inherently sort of de facto make it self-organizing?
Yeah, I think that's absolutely right. With a slight twist. So it is not self-organizing because it has those features. It is just self-organizing because it exists. So one deflationary aspect of the free energy principle, it's not a prescription for life or self-organization. It's much simpler than that. It just says, if things manage to self-organize themselves into some characteristic states, and you sort of obliquely referred there to random dynamical systems, and implicitly non-equilibrium steady states, that would be the sort of mathematical description of something that exists and has self-organized to this kind of steady state. And the particular kind of steady state we're talking about here is not the equilibrium or equilibria that you'd find in statistical mechanics or physics of closed systems. These systems, by definition, are open and in exchange with their world. So this is a physics of open systems that are usually far from equilibrium, but they still have these steady states. And all that free energy says is that if something exists in the sense of repeatedly revisiting and occupying a restricted number of characteristic states, then it must show these properties. And these properties are the properties described by the principle of least action. So it will look as if it is doing its self-evidencing. It will look as if it's doing its predictive coding. And furthermore, in acting, it'll look as if it's searching for the right kind of data in order to maximize the evidence for its implicit model of its world. So the predictive processing story, the narrative, the low road, is a consequence of existence, where existence just is defined in terms of a system that does not dissipate. And what you've also cleverly done there is introduce the notion of a Markov blanket, which, from the point of view of the free energy principle, is absolutely central. But we are now talking about things in the language of of physics, and as such, one has to address some very basic problems, questions which people like Schrödinger, and many people before, many people after, have addressed fundamental questions about the nature of things. And one of the first things you have to tackle is, how do you individuate something from something else? You and I are clearly distinguishable from our environment. I can look at you, I can see you as something that is not the door behind you or your bookcase, and indeed the books on your bookcase are other things that can be individuated. And that's quite remarkable, because a lot of the universe is like some gas or some soup, where it's very, very difficult to identify something in this melee of interconnected dynamics, but there's something about things that is sort of self-defining, in that they can be separated. There's a boundary of sorts between you and everything that's not you, and that's the role of the Markov blanket. Put another way, the Markov blanket is basically that interface that allows you as something with your internal states to be open to the rest of the universe. And so it's something that, if you like, individuates or separates you from everything else, yet at the same time plays the role of a way of you being open to the rest of the universe. So the Markov blanket literally mediates the influence of the universe on you and the influence of you on the universe, and yet surrounds you and insulates you in some statistical sense, so that you can be individuated or separated from the rest of the world. So that the Markov blanket is quite crucial, and leads to all sorts of implications. My favorite is that now we've got a physics that can be applied to any random dynamical system, where at its heart is a partition of two separate kinds of states of being, or states, those that belong on the inside of a Markov blanket and those that are found on the outside. And that means, for the first time, you can now start to talk about how the inside states represent the outside states. Notice, without that separation, you can't do that. The dynamics and the probability distributions over just one set of states can only be articulated in terms of the probability of being in a particular state, or the probability of a particular path through state space. But now I've got this separation by appealing to this notion of the Markov blanket, which now enables me to talk about the internal states in some way holding probabilistic beliefs about the external state. So now we have an aboutness and a connection now between the physics of the internal states, the neural dynamics, the thermodynamics of the internal states, that can also be read in a representational sense in terms of holding beliefs about, subpersonal probabilistic beliefs, representing in some elemental sense something else, something on the outside. And that's, if you like, the physicist's version of predictive processing, where you're trying to predict or represent or have fantasies, explanations, hypotheses, models of the causes of your sensations. Because, of course, those causes are on the outside. All you can do is register the sensory signals from your retina or from your skin or from your ears or from your gut. You don't know what's actually going on beyond your sensorium, beyond your Markov blanket. But now you can read those internal dynamics as machinations, as if they were trying to infer what was happening on the outside, as if they were trying to represent the causes of their sensations, namely the external states. So yeah, Markov blanket, really important.
Yeah, and sort of what was it? How was it? So with talking of Markov blankets and the systems, system, with the Markov blanket. So essentially, as well as that any system is attempting to minimize its negative marginal likelihood, or basically put an upper bound on its surprise. And is this because if it didn't, it would essentially be, I guess it wouldn't be a thing. It would be I don't know if it would be isomorphic with its environment, but it would just dissipate. And therefore, so whilst we're modeling, or any, say me, for example, in this instance, as a whole organism, I have to model my environment. Do I also, though, have to model it in such a way that there are constraints?
Yes, I think that's, again, absolutely correct. And again, I've noticed you've started to introduce even more technical terms like surprise and marginal likelihood. So perhaps it would be good just to say that all of these things are the same thing, and
Yes.
and then that'll, I think, remove a lot of the mystery and the potential confusion around the different ways of expressing this. So we've talked about prediction errors, which is basically the discrepancy between what I predicted and what I'm actually sensing at the moment, given what's often called a generative model. So a generative model is just a probabilistic description of the joint occurrences of causes and consequences, where in this instance, the causes are out there in the world, and the consequences are the way that the world influences me, basically my sensations that are impressed upon my Markov blanket, the sensory information that I have at hand. So that generative model can generate predictions of what I should be sensing if my generative model was correct, and the quality of those predictions can be scored by a prediction error. So it's a very high prediction error. That's very surprising. I'm very surprised to get these sensations. So immediately you've got this sort of, you can say that the surprise just is the amount of prediction error. Technically, if I was an information theorist, how would I write down the surprise mathematically if I say Shannon? Then I just need to score the implausibility, or how surprising these particular data points are, these sensory impressions are. And I can do that just by writing down the negative log probability of getting these sensations under a generative model, conditioned upon a generative model, say me. So that quantity is, I repeat, the negative log probability of some outcome, some observable outcome, some sensory data given a model. That quantity is in information theory called the self-information. Tribus call it surprisal. It just is the surprise. It can be measured by prediction error. The free energy is an approximation to that self-information. And as you correctly stated, it's not equal to, it's by construction always slightly bigger than. In physics, in machine learning, it's slightly smaller than. So in machine learning, they take the negative free energy and they call it an evidence lower bound. It's an upper bound in physics. So you're trying to minimize the free energy and implicit, therefore, minimize your self-information, minimize your surprise, minimize your prediction error. All of these things are exactly the same thing. It's just people using different conventions and different words in different settings. The final way of labeling this quantity, that log probability of the sensory data given a model is the log evidence. It's also, as you rightly noted, the log marginal likelihood. Why is it a marginal likelihood? Because you've marginalized away, you've averaged away all the actual parameters and unknowns that actually generated these sensations. So you're just left with the overall model. So marginal likelihood, model evidence, free energy, prediction error, surprise, surprisal, self-information, and notice that the average of self-information is entropy, and therefore uncertainty. These are all basically different words for exactly the same quantity that we're trying to extremize, in some instances minimize, or the negative of this quantity we will be trying to maximize, as in self-evidencing.
Yeah, it's great you said that, because that was a question I had, which was sort of around the free energy principle is very much, it seems as though, particularly when you start to talk about predictive processing, you sort of get this Bayesian account and Bayesian terminology. And I was sort of wondering at times, I actually wrote it. It's essentially, it's almost like different languages for the same thing. Like, is that right?
Yeah, no, it's absolutely right. Yeah, I mean, predictive coding has sort of taken on a rather glorious meaning in the neurosciences, but was originally developed in the 1950s just to compress sound files. And compression is an important part of maximizing the marginal likelihood or maximizing the Bayesian model evidence. But at heart, it is also just a Bayesian filter. So if you're an engineer, you would recognize predictive coding as something called a Kalman filter. Certainly a linear version of predictive coding would be equivalent to a Kalman filter. That is the simplest example of a Bayesian filter. So you're absolutely right. This is all the same kind of mechanics. And I repeat, at its heart, these are just paths of least action that are trying to minimize variational free energy. That can be read as Bayesian filtering. They can be read as predictive coding. It can be read as predictive processing. It can be read as self-evidencing. You take your pick depending upon your favorite lectures at university, or what your mentors and the people that you have to teach, whatever rhetoric they're most comfortable with. Yeah. But under the hood, it's all the same.
Sure. And given that it's all the same, is it all the same in that? Now, I don't know if I just overlooked these two, I don't know what you call them, values or densities. But more recently, I was reading a paper, I think it was Anna Seth and someone else, because it was quite dense in its mathematics, which sort of I struggle with at times. But it spoke of the recognition and the generative, and the generative densities. Yeah. So it is, when we talk of prediction errors, surprise, are they all emerging from the the difference of the distance between those densities, or is that different? Is that something else?
Yeah, I mean, you're getting now into the weeds of the technical vocab that you bring to the table to sort of articulate and possibly even write down the maths or the software to implement these things. So technically speaking, what you're talking about is the distinction between a generative model and a recognition density, sometimes also referred to as a variational density. And when people talk about generative model, technically they're talking about a probability density. They're just talking about a joint probability distribution for continuous states is known as the density over causes and consequences. I repeat, the unobservable, latent, hidden states hidden behind your Markov blanket that are generating your observable sensory information. So the generative model is the generative density. It's a description of, I repeat, the way in which sensations are caused. And this is very distinct from the variational density or the recognition density. So the recognition density is a description of your Bayesian beliefs. These are, again, I'm using beliefs in a very technical sense here, just as conditional probability distributions that in the context of variational inference now become isomorphic with the variational density. So the variational density is just a conditional probability distribution, a Bayesian belief about the causes of your sensations or the causes of your data. It doesn't exist physically, so physically it's always encoded by the parameters of that variational density that we fondly assume corresponds to neuronal activity, or if they're variational densities over the parameters, it could be synaptic efficacy, very much like connection strengths in a neural network. So the actual biophysics of the brain is written in terms of neuronal dynamics and plasticity, in terms of real variables, and those real variables now stand in for the sufficient statistics or the parameters of a variational density. So expressed like that, if I now want to minimize my prediction error or minimize my surprise, and I want to articulate that or understand that mathematically from the point of view of somebody wanting to express belief updating in purely Bayesian terms, what that would mean is changing my biophysical brain state to encode a variational density or conditional probability distribution or Bayesian belief until it changed so that it minimized the prediction error or maximized the marginal likelihood. How do I do that? Well, mathematically, the only tractable way of doing that is basically either can be articulated in terms of minimizing prediction errors, and that's a very generic sort of approach. Perhaps we should just take that as effectively the sort of variational Bayesian inference that most people subscribe to when they talk about predictive processing or predictive coding in the brain. So how am I going to change my beliefs in order to minimize my prediction errors? Well, I'm just going to change my mind until what I believe about the outside provides predictions that are almost the same as what I'm actually sensing. So the variational density now moves around. It is another way of describing this is an approximate posterior belief. So when you talk about Bayes' rule, you have in mind the notion of Bayesian belief updating. And again, I'm talking about beliefs as probabilistic representations. And the idea is that you have some prior belief before you see some sensory data. And then the sensory data comes along, and then it does something called Bayesian belief updating, or you revise your beliefs to make them into posterior beliefs after you've seen the data. So that the sensory evidence or the sensory data comes along and moves your prior belief into a posterior belief, and that movement is called Bayesian belief updating. And the pressure of, if you like, the force that causes you to change your mind is just the prediction errors. So when the prediction errors cannot be resolved any further, there's no more force in terms of driving your neuronal dynamics to change your mind, to change the variational density. The twist here is that in order to compute the prediction error, you have to be able to generate a prediction. So that process of Bayesian belief updating your variational density or recognition density or your posterior or approximate posterior density rests upon a generative model, because in order to evaluate the prediction error, technically that's a gradient of the variational free energy, you have to have a generative model. So it'll always look as if you are appealing to a generative model to generate your predictions, to evaluate the free energy gradients or the predictions, to evaluate the prediction error, so that you can know how to change your mind in a Bayes optimal fashion. That's a little bit round the houses, but you did ask.
Yeah, no, it's brilliant. It's really good. Yeah, it's great. And it makes me think a lot. It will be good after I sort of just wanted to kind of finish up on asking some questions sort of more broadly around the free energy principle, and then maybe sort of go, which we've been talking about, predictive processing, but to sort of maybe talk about that and how it's instantiated sort of cortically, and how and the consequences of that for explaining perception and psychopathology. But prior to that, I'm just curious with if the sort of almost maybe in a way the philosophy of the free energy principle, and perhaps where it's misinterpreted, and maybe even I've misinterpreted it, because you said at the beginning, it doesn't, it's oh, what do you say, it's almost like so simple that it's not necessarily. So I'll put this. So in the 2018 paper you authored with others, the Markov blankets of life, which is a fantastic paper. This is directly quoted. This teleological Bayesian interpretation of dynamical behavior in terms of optimization allows us to think about any system that possesses a Markov blanket as some rudimentary or possibly sophisticated agent that is optimizing something, namely the evidence for its own existence. This means we can regard the internal states and their Markov blanket as in some sense autonomous. When I read that, and again, I think you somewhat explained this before, you answered that the free energy principle doesn't go there, there being what I'm about to ask. But why do systems care? What almost is this just sort of an axiom akin to like an ontological informational primitive, this kind of optimization?
Yeah, that's a great question. I think the word you were referring to was sort of deflationary.
Yes, that was it. Yes.
But I also sometimes use the word tautological. So
Yes,
remember that we were saying before that the free energy principle is not a prescription for life. It's not if you do this you will live. It's the other way around. If you exist and live in some characteristic state, then you must conform to the free energy principle. So in that sense, it is deflationary. It's not if you like a law for survival. It is just a description of things that survive. However, once you've got that law, once you've got a principle, and I repeat that this is very, very similar to a principle of least action you find in classical mechanics. I should also note, just out of interest, it's also a dual to James's maximum entropy principle, another principle. So these are mathematical principles. What are mathematical principles? They're methods, they're tools. What would you do? You would apply. What would you apply it to? Well, you'd apply it to a particular generative model, and you'd be able to simulate the self-organization of this particular generative model. And that's exactly what we do. And perhaps we'll come on to this later. Then we can ask questions. Well, what kind of behavior would ensue if I change these prior beliefs in this generative model? But the point I'm making here is that the free energy principle is a method. It's not a philosophy. It's a simple set of mathematical rules that allows you to simulate sentient light self-organization. Having said that, you will find some cheeky and glorious celebrations of what this would look like, as of the kind I think that was it Michael Kirchhoff's was the
Yes.
first author.
Yeah, that's it. Yeah.
I think that because you've got this this expression of this principle of least action in terms of a Bayesian mechanics or Bayesian belief updating, that does license you to put a teleological interpretation on stuff that things have to do if they survive. So I think you are licensed to say it looks as if there is a teleonomic, or there's a teleology here. And what does this teleology look like? Well, it looks as if the behavior of this system's self-organization, is aspiring to maximize the marginal likelihood of the data under generative model, or to acquire the best evidence for its generative model, or it looks like a little Bayesian statistician. But these, if you like, are teleological interpretations that you and I and Michael have actually put on the kind of dynamics that follow from an application of the free energy principle. So these are interpretations, these are stories that you tell.
Right.
There is an interesting twist there, though, which I just wanted to pick up on, and perhaps I shouldn't because it's going to distract you, but I think this is really nice, and it just speaks to something you introduced earlier on, which is the fact that the variational free energy is actually a bound upon the self-information or surprise or the log marginal likelihood. It's not the actual most likely path. And that's because in order to actually evaluate by applying the method, the surprise or the surprise, you actually have to approximate it with a bound approximation. And this is what Richard Feynman brought to the table when he was trying to evaluate the probability of paths that small particles, say electrons, might take. He couldn't actually solve that probability distribution, that integration problem. So he converted it into an optimization problem by inducing a variational bound on the log marginal likelihood that just is the variational free energy. So what he did was convert an impossible marginalization problem into a tractable optimization problem. So as soon as you tell the self-evidencing story, as soon as you put a teleology onto the basic mechanics and you appeal to the free energy, you've now said that it looks as if this brain is solving an optimization problem because this is exactly what the free energy brings to the table. It converts an impossible integration statistical problem into an optimization problem. So it now looks as if everything's optimizing their free energy, and that optimization can now be read as things like self-evidencing and everything else. Does that help?
Yeah, very much so. And yeah, it does. It's just fascinating because I can't help but when I almost want you see a sort of a teleology in it, and there's almost like, I know, it's only it's, I guess it's, I mean, I don't know, maybe you disagree if I were to say it's a map for some territory, but because you've just talked about, it's more of a method to interpret. But given that, and again we'll sort of go on to it, but when it's been applied and in like predictive processing and stuff, and and what I think is also be good to quickly mention is how Markov blankets and systems, the sort of nesting of them and how they go all the way down, and from if we think of brains and us as organisms, and then brains, and then sort of microcircuits, and then neurons, and then cells, it's kind of yeah, it's what am I saying? I suppose what I'm saying is I can't help but wonder what the territory is in terms of this optimization. Yes, but I suppose that speaks to maybe somewhat of my whilst I studied psychology, and that's what I'm very much interested in, and sort of clinical psychology is I guess like many people that I have a sort of a philosophical inclination towards things. But yeah, it would be good, I suppose, as we maybe then move into predictive processing. If I suppose what's great about the free energy principle and systems with Markov blankets is that, yeah, they can be nested within each other, and that this optimization, this desire to sort of minimize entropy and stuff, it's yeah, it kind of goes all the way down in sort of different layers or sort of levels, so to speak, and that it somehow emerging from that is, in this instance, you or I.
Yeah, again, you're bringing in so many really foundational points here. In terms of the map and the territory, you need to speak to people like Maxwell Ramstead, who has a beautiful spiel about the distinction between the map and the territory, and as being that part of the map, which is the map, doing the mapping of the territory. On a more simple view, from my point of view, from inside my head, My generative model is a map of what's out there, the territory out there, and it's always going to be much simpler because there are certain compression or complexity minimization constraints that inherit from self-evidencing or maximizing the marginal likelihood or minimizing my prediction error, which means I'm going to have to coarse grain. I'm going to have to dimension reduce in the right kind of way to get the good map that generates the good enough predictions to keep my prediction errors small in a way that generalizes in my sensed world, and that sensed world, as you're intimating, itself is composed of things, and every time you say there's something out there, you're saying there's another Markov blanket. And of course, even my brain, even my body, is composed of things. It's got organs, and organs have cells, and cells have organelles, and organelles have large proteins, and large proteins have molecules, and all the way down and all the way up to the biosphere. So you're absolutely right that in order for me to self-organize at my particular time scale and keep myself within these characteristic states, the states, interestingly, that are actually the states that I am not surprised about being in. So they're actually part of my generative model, that define me in my characteristic states. In order for me to do that, I have to be living in an environment of things that permits that. And furthermore, for me to exist, all the structural and functional integrity of all the constituent Markov blankets of my brain regions and my organs and all of their organelles and all the way down to quantum physics, all have to be in play. So in order to exist, there has to be Markov blanket-like structures all the way up and all the way down. And then the interesting question is, well, what's the distinction between a Markov blanket or indeed a partition of any state space into a very large number of Markov blankets at any particular scale, and the scale above and the scale below? And it turns out, and unsurprisingly, that it is the characteristic difference is a separation of temporal scales. So the environment in which I live, and this could be, an eco-nation. It could have cultural aspects. So we're talking about sort of the things that constitute my environment, read from the perspective of evolutionary biology, are things, and they have to change very, very slowly in order for me to, at a slightly faster time scale, grow and develop and learn and experience and do my self-evidencing. In the same spirit that I have to, at a particular time scale, grow and learn and develop and learn to make sense of everything in order for my cells and my organs to grow and turn over at a slightly faster time scale. So you've got this picture, exactly as you paint, of Markov blankets within Markov blankets within Markov blankets, all the way down and all the way up. But with the interesting twist that the more encompassing, larger scale Markov blankets are changing and lasting much longer than the Markov blankets that they encompass, or at the scale below. So that brings something quite important to the table, that when we talk about this sort of non-equilibrium steady state and being in characteristic states, there's a particular time scale for which that is true. I am going to dissipate ultimately. My Markov blanket at the end of my life will be dissolved, and I will dissipate in a true entropic fashion, and I will cease to be a thing. I will not be individuated because I will have dissolved or decayed in some way. In exactly the same way that many of my neurons are turning over. Well, let's actually take synapses. I mean, synapses will be turning over every few minutes in certain parts of my brain, if not even on a time scale of seconds. This is more like a fluid. But for the duration that they are identifiable as this synapse, there is a particular time scale at which the free energy principle applies, and then it doesn't apply. But it does apply for longer at the larger scale that provides the context for the faster turnover at the level below. So some really interesting issues there. So for example, can you deploy that that mathematics and that mechanics in evolutionary thinking? Can we look at evolution as a free energy minimizing process? And of course you can, and people have started doing that for decades now. So the usual story here is that natural selection is nature's way of doing Bayesian model selection. What is Bayesian model selection? Well, it's selecting that model or that phenotype that has the greatest marginal likelihood of being in a population. This is just adaptive fitness. So adaptive fitness is another thing you can now lump with surprise, prediction error, free energy, self-information, marginal likelihood, model evidence. These are all just descriptions of the same fundamental quantity, which is the likelihood of being in this state. And all we are saying is with these nested free energy minimizing processes, or things that look as if they are free energy minimizing processes, is that things just occupy the most likely paths or narratives or states of being. And when you can separate things from other things, it looks as if they have this teleology. You use the word desire. People also use the word purpose. So it looks as if they have purposes and desires and goals, and that they are attaining or behaving in a way that optimizes their adaptive fitness. But under the hood, really, they're just existing.
Yeah, it's I mean, so I had this sort of thinking about bringing this up later, but it fits very, very neatly with what you've just said. Now, it's the person's work I've heard on a couple of podcasts. I think you've been asked about this person and whether you're familiar with their work. That being, and you said not too familiar, and that being, at least at that moment in time, and that being Donald Hoffman. And his work is very much, in accordance with evolutionary theory. And I wrote down, it just appears to me that the free energy principle is congruent with that work, specifically from what I can gather. Sort of, I think he uses sort of like evolutionary game theory and stuff, essentially stating, he sort of termed it fitness beats truth theorem, which appears to me to be this sort of minimizing of surprise, or rather that organisms which minimize their negative marginal likelihood, perhaps through mutations and stuff, will outperform others, maybe due to like metabolic efficiency and stuff. Does that make that seems to me like an extension of what you've just said, or at least it's somewhat an
no, absolutely. I'd been again in a slightly more deflationary way. It will look as if these, they are surviving because they're more adaptive. So this would be the teleological reading of the fact that they exist at this point in time. But that is absolutely right. And yes, no, I've now realised who Donald Hoffman.
Yes,
Yeah, and I realised who he is. He's actually a correspondent of one of my friends, Michael Evan. So it's all coming together now.
Oh, so, yes, yeah, Michael Evan, yeah.
And yes, I think those ideas are absolutely consistent with the free energy principle. I think they are nice stories that have a teleology which people can get their head around. Yes. I think that's true, and they're certainly endorsed by the sort of less teleological application of the free energy principle at this scale of self-organization. You mentioned efficiency. I think it's probably worthwhile just spending 1 minute celebrating. So part of this self-evidencing, part of this occupying the most likely paths or trajectories through some abstract state space entails a maximum efficiency through the principle of least action or least effort. And that unpacks very gracefully when you look at the statistical interpretations of free energy or log marginal likelihood or the log model evidence. So you can always write down the log evidence as accuracy minus complexity. So that's just the way it is. Which means that, and just open brackets, this is one rearrangement of James's maximum entropy principle, that you're trying to minimize the complexity by keeping your options open so that the entropy of your beliefs is as broad as possible. So you're not committing to a particular explanation. You're not overfitting the data, as it were. So this is absolutely crucial in terms of anything that looks as if it is self-evidencing or a free energy minimizing process, that it will be modeling its world in an as accurate a way possible, but with the minimum complexity. And that minimum complexity is what makes it the most efficient. It's the simplest way of providing an accurate account of your data. So this is, if you like, Occam's principle realized through a variational treatment. Then you can either go to the free energy principle or James's maximum entropy principle, or more specifically maximum caliber principle, to see where that comes from. But it also has really important thermodynamic implications that you hinted at with the metabolic efficiency. So there are physical laws that say that the degree of belief updating, or the amount of information that I have to erase in order to update my beliefs, has a thermodynamic cost. It takes a certain fraction of a joule to destroy or to change one bit of information, which tells you immediately that the complexity that we're trying to minimize has direct metabolic and thermodynamic consequences. So if I don't do it efficiently, if I don't minimize the complexity, which actually, interestingly, is the degree to which I change my prior beliefs into my posterior beliefs, it's the degree to which I've to change my mind, that we're trying to minimize all the time. We're trying to, it looks as if, my apologies, we are trying to build those prior beliefs that need the least revision in order to account for some new experience or some new data. And that is the most efficient, both statistically, but also thermodynamically, because it costs energy, metabolism, in order to move my beliefs. So it looks as if all free energy minimizing processes are trying to build models of their world and actively navigate and engage with that world in a thermodynamically as efficient way as possible. So it gives license to this heuristic that part of adaptive fitness is metabolic and thermodynamic efficiency. It also has big implications for current artificial intelligence as well, which is actually going in the opposite direction. I suspect that's another story if you're a psychologist.
Yeah, and with the what you were saying there, I mean, so in a sense, across, if we talk of large sort of temporal scales, time scales, it's what explains this kind of you've spoken. I'm getting confused as to whether I can't remember if if you've mentioned it already, or if I'm just thinking of when I read it in a paper. But this sort of we are models and modular environment, and I suppose therefore across time with this minimization or this trying to reduce, sort of have the simplest account maybe of our sort of self or our world, leads to like an ecological niche, right? So in a way, it leads to some sort of narrowing of perception across large timescales.
Yep, no, I think that's very astute. And I mean, you can just see evidence, all around you of this. I guess what Andy Clark would call a sort of designer environment, and other people might call sort of niche construction, but niche construction that enables you to make the most efficient and simple sense of what's going on. So I can see, but you can't. But I look at your room and I see a compendium of straight lines and uniform surfaces. So these are exactly the kind of causes that have been co-constructed, not by you, but the people who built your house in this instance, or perhaps you decorated it. But they have been constructed exactly to provide the most efficient stimulation of your edge detectors in your brain, the line detectors and the surface detectors, that in turn are learning to be good line detectors and surface detectors, because this is a kind of co-constructed world that we live in. So that simplification, I think, is a beautiful example of this, if you like, recursive application of the free energy principle, not just to the phenotype, but to the niche in which that phenotype is embedded. That as much as and this is a sort of variational niche construction story, as much as the phenotype is trying to learn about the environment is also trying to learn about the phenotype. So that, you know, the canonical example here is a desire path or an elephant path, where you take a shortcut and you wear away the grass across a lawn, for example, and that can be read as the environment learning about you, but also plays a very crucial role. That if the environment contains lots of conspecifics, then if I see this path, I know things like me are likely to take this path, this particular shortcut. So this also enables, if you like, a story of cultural niche construction, where you've now got signs and deontic cues that we all build to make our worlds our worlds much easier to read and to get a grip on. Again, in the most efficient way, so I don't have to revise my beliefs or do lots of inefficient belief updating. Everything is as simple and as efficient as possible. And of course, you probably want to say yourself, but you know, the ultimate of this is language. It's not just signs that I leave around, road signs, for example, or social norms that are co-constructed, but because our very language, our ability to share our beliefs and to resolve our surprise and our expected surprise, namely uncertainty, in the most efficient way, is a beautiful example of this this kind of self-evidence and this kind of sense making.
Yes, and actually, I think particularly, that's in my mind anyway. It's that maps very well onto. We will get onto, but sort of predictive processing, and particularly sort of with psychopathology, and also how belief updating occurs perhaps through psychological therapies, through this sort of interchange of priors. And actually, it's really interesting because I only recently sort of stumbled on his work, albeit I'd heard his name, you know, I've seen his name in many papers and stuff. But Chris Frith, you're obviously familiar with, yeah. And he actually wrote a paper, I believe it was published this year. It's really great. It's on culture and sort of priors, and how we sort of, you know, communicate our priors and almost imbue each other in a sense with priors. And just lastly, on this sort of kind of evolutionary timescale, I wanted to sort of talk about canalization, because I know that it's a sort of a way to describe, or I believe it's a way to describe this sort of principle of least action, and it can be sort of yeah, sort of spoken about, or you can talk about it at different varying timescales. What is canalization?
Well, I read it basically as you were effectively describing it, in relation to sort of a Waddington landscape, but specifically this is the landscape of free energy. And as you intimate, that free energy, or the time or the path integral of that free energy, which is the action, which is part of the principle of least action. So in physics, an action is just the average over a certain period of time, and that time can be on an evolutionary time scale, or it could be on a developmental time scale, or it could indeed be you know, a perceptual time scale. Whatever the you know, the dynamics are going to be governed by dynamics on a Waddington landscape that is effectively the free energy. So remember before we were saying that the prediction errors are free energy gradients. Then what that means is that neuronal dynamics being driven by prediction errors are always rolling downhill. So you have in mind a landscape that is constituted by every, if you like, probabilistic state of being, or every state of my variational density or my recognition density or my fantasy about what's causing the world, then for every particular inferential state parameterized by my neural activity, there's a corresponding free energy, and that creates a landscape, and then I can understand my neural dynamics as flowing downhill. Now, the canalization, sorry, I should also say not just my neural dynamics, but of course my neural development, or indeed genetic drift. At any time scale that you can identify things, then this sort of landscape, this gradient descent will be in play. So the way that I look at the canalization, which is a really important concept, is that very much in the same way that a river will carve its own riverbed, the more that you traverse this particular ravine or free energy minimum, surprise minimum, the more you will erode that particular valley or course of action, so that you are now literally digging your own rut. It's interesting that, you know, this is exactly the thing I had in mind when talking about the desire path or the elephant path. You are carving, by just using it, by pursuing that path of least action, you are leaving a trace on the environment. And exactly the same mechanics can be brought to the table to understand the Waddington landscape that is constituted by a variational free energy. The more that you circulate around this landscape, continually descending it, there's a little bit of a twist here that the landscape is itself moving in time, because nothing is stationary. So you're always chasing downhill, but the hill is actually moving at the same time. So you never actually get to the bottom. But the same rules apply, that you're carving out these paths most likely trodden, and you're more likely to pursue that path the next time around, provided there are no catastrophic changes to your environment. So that notion of canalization, I think, is very important, and speaks again to this sort of circular causality, that, you know, the way that I engage with my world changes that world, which can reinforce the way that I engage with it. So again, language, you know, the very fact that I am able to converse with you rests upon two things. It rests upon the fact that I can learn language, but it also rests upon the fact that you are using language as part of a co-constructed cultural niche in order for me to be able to learn it. So that language causes itself through our use of it. So I think that's a beautiful example of this kind of canalization, this emergence of order and sparsity and efficiency, that sometimes is regarded, I think, as paradoxical. But on that view, I think is quite a natural thing to, you know, to see.
Sorry.
No, carry on.
It's just come to my mind. It just out of nowhere. To an extent, then, because canalization, if we talk of psychopathology, it can sort of explain psychopathology, and perhaps whereby you've got this sort of you sort of embed a path or kind of out of this path, but then as you said, that the mountain or the rocks, you know, they're moving, and I suppose you know, the environment is always changing, and that can explain this sort of like why beliefs earlier in life sort of become they don't accord with the environment in the same way, or they don't help you as an organism. But what just came to my mind then was this talking of this canalization. In a sense, it explains extinction of species, right? In the sense that if you have a phenotype which has kind of kept on carving itself, but then the environment changes, I don't know, let's say other things are happening in the ecology or, you know, the environment, and that path no longer, does that, I don't know, I'm just sort of like, it's just come to my mind now. Does that make any sense?
Yeah, no, absolutely. And I think you can take exactly that sort of construct and apply it to the psychopathology that you were talking about. That, you know, if the world changes in some characteristic way, so that the whole landscape of free energy, and people like Eric Reifelt and Julian Kiverstein would call it, so the field of affordances, you know, that dictate the way I should move through my canalized free energy landscape. if that changes, then I will then my particular ruts, my particular canals will no longer be fit for purpose.
Yes.
And and then you can just use simple heuristics like I become stuck in a rut, which is fine as long as nothing changes. But if I
Yes.
lose a loved one, or I have a debilitating illness, or something changes in relation to my social support or employment, then that rut is no longer optimal. But because I've worn it down, it sometimes can be quite difficult to get out of. And of course, if the landscape changes catastrophically with asteroids, or indeed the sort of a bereavement experience, then that the landscape that is formed from my prior beliefs that contains these ruts and these minima and these canals that can be canalized will now be destroyed. And my normal way of doing things just is not fit for purpose anymore.
It's only just in talking about it now, this kind of concept or this idea or this construct of canalization, actually how, at least for me anyway, it's so useful. And it, yeah. Yeah, and I suppose then it would be good to talk about, I suppose, an extension of all of this, but more specifically with predictive processing. And so I guess the way it might be best to start, could we state that, I think we've answered that predictive processing is essentially a transposition, or it's at least a similar account as to what the free energy principle is. It's a sort of just a different language describing the same thing. Oh, and I wrote this down, what you said earlier about, it refers to the same processes, similarities, for example, negative marginal likelihood, marginal evidence, prediction error, surprise. Which I don't think you mentioned, but I'm not sure how much we've spoken of it, but precision. And at least in predictive processing, it appears as though precision plays a very, very central part in organisms being able to adapt to perhaps adaptive, for example, things like adaptive active inference and things like that. I guess precision is very important. Would you be able to sort of, just give sort of continue that?
Yes, yeah. Again, that is a really important observation. So much of the application of things like predictive processing and the free energy principle to psychopathology, so things like computational psychiatry, ends up talking about precision. Interestingly, also, if you read people in philosophy, particularly people like Andy Clark, they will talk explicitly about the minimization of precision-weighted prediction errors. So implicit in that focus on precision-weighted prediction errors is it's not just the prediction errors. So the actual gradients I was talking about before are the prediction errors multiplied by their precision. So if I am in a very noisy environment with very low signal to noise, then I may have all sorts of prediction errors because I can't predict what's going on. But I know that because my sensory information is very imprecise. So I can downweight the prediction errors and basically ignore them. But if I know that I'm in a very precise environment where all the information is arriving with a very, very high signal to noise, then if I make a mistake in my predictions, I should attend to that mistake. I should afford those predictions much more precision, much more reliability. I can be much more confident that this kind of news, the prediction error being the newsworthy information, deserves my attention. And simply by assigning or weighting the prediction error in proportion to its precision or its reliability, I am therefore able to pick out those bits of sensory information that have privileged access to my belief updating. So this has all the hallmarks, if you're a psychologist, of attention. It can either be an exogenous attention that I didn't predict that happening, and automatically quickly my attention is drawn to this, or it can be I know in this situation that the news is going to be very reliable, so I'm going to pay attention to it, as in say a Posner paradigm. So there's a very, very close relationship between precision weighting, and notice that the precision itself has to be estimated and predicted, and attention and a selection, and of course ignoring and sensory attenuation. So just to sort of complete the story, from the physics point of view, it is interesting that the precision manifests as the depth of those canals or ruts. So if I'm in a very, very precise state of mind, then I am not going to deviate when following a particular valley. So I've got a very, very sharp minimum, a sharp value where the whole landscape is deeply carved out with lots of technically a high curvature. So the curvature corresponds to the precision. So something that is very, very sharp has a high precision. Something that is very, very shallow will have a low precision. So it means I've got a bit of latitude to wander around without incurring a free energy cost. And this is what I was intimating before about James's maximum entropy principle, not committing to a particular option. I've got a bit of latitude here. It's just one way of expressing Occam's principle, or the most efficient way to build beliefs about things or to explain things. So you have this notion now that a very precise landscape is the kind of landscape where you can very easily get stuck in a rut. And you get another kind of landscape which flattens the landscape, as it were, and reduces the precision everywhere, enabling you to explore other options. I think that's going to be relevant when you come on to talk about therapeutic interventions that are aimed at changing the precision with which certain beliefs are held, which of course immediately speaks to the psychological story, which is you're talking about attention-based therapies, either mindfulness, meditation, or any drug that acts upon the attention mechanisms. So that brings a third, if you like, way of reading precision from the point of view of a neurophysiologist and possibly even a psychopharmacologist. So how would I actually implement in a brain the precision weighting? How would I implement attentional weighting to this kind of prediction error? Because I have estimated that this has very precise information. Well, what I can do is I can just increase the excitability of neurons encoding that precise information, namely reporting the prediction errors. So if I can increase the excitability or change the excitation inhibition balance or increase the postsynaptic gain, then I can implicitly attend to or increase the attentional gain to that kind of information. So now what you've got is a three-way link between attention, mathematical precision, and the potency with which prediction errors have access to higher belief updating, and neuromodulation, the modulation of the gain of certain neuronal populations, and the kinds of drugs that would exert an effect upon that. And I'm thinking here of things like psychedelics that
Yes.
are notorious for changing the gain of key populations that people think are responsible for reporting predictions and prediction errors. So exactly, you've now got this sort of three-way link between sort of an attentional story, a pharmacological story that necessarily entails all the kinds of drugs that you'll find used in psychiatry and in fact most neurological disorders that are acting upon the excitability or the gain, the neuromodulatory transmitter systems that set this kind of gain control, and the mathematical or computational aspect of belief updating, which can either cause you to be in a rut or can free you from that rut should you be able to sort of rebalance the precision, especially in sort of cortical hierarchical predictive coding models. So precision really important.
Yeah, very much. And that's which I know you've done work with Robert Carhart Harris and
Robert,
and I think the acronym is Rebus.
That's right. Yes.
Yeah.
Yes. Well, that actually has relaxing this sort of relaxing these sharp minima in the acronym. So it is exactly that flattening of the landscape, enabling you to explore different options, different ways of being, different ways of understanding and modeling your world.
And I suppose depending on the person or what they're sort of experiencing, you're aiming, I suppose, to either relax or maybe even narrow that almost canal at different levels of the hierarchy. So, for example, I know that it's Catherine Schmack, I believe, who works at it's fairly it's completely the Crick Institute, and have been looking into sort of psychosis and inducing sort of psychosis in mice. He talked about how you and I imagine as well, probably in fact I know they cited much of your work and people you've worked with around this idea of how, say, in psychosis, precision, I suppose that maybe they are only theories, even though there is perhaps evidence to account for or to support them, but that precision, say in hallucinations or psychosis, with hallucinations, albeit actually because often hallucinations and delusions are sort of spoken of as sort of being sort of distinct, but actually I think in this paper I read recently, they were able to account for them as similar, basically by saying that at the lower part of the hierarchy, the cortical sort of hierarchy, where we're dealing with sort of sensory stuff, that it was either very loose or very rigid, and then higher, and as a sort of a consequence of that, at the higher, where we're dealing with the sort of more abstract sort of interpretations of that sensory information, it was much more, again, I can't remember, rigid or loose priors. So it's fascinating, and I know you've done a lot of work on sort of psychosis and the sort of idea of false inference. You can explain, I suppose that's a great thing, it explains many things like OCD. I've been thinking about OCD as this kind of it's a because OCD, I suppose you have your sensory input. It might be proprioceptive, it might just be a sense of something, and then there's this belief, and then there's a compulsion, or sort of a need to act in a way and to kind of reduce that surprise. But what happens is, though, across a larger timescale, it's not actually resolving the surprise. So it's interesting. So I sort of think, well, where's the precision there? Is it because that what the individual is doing, they're not actually necessarily, maybe it's too precise on at a certain level. And it makes sense because say OCD, and you spoke of mindfulness and meditation and things. I suppose it's trying to actually, I suppose, that's what it is. It's a relaxation in a way. You're trying to relax the person's sort of beliefs in a way, because often the person becomes so entrenched in an interpretation of their sensory, perhaps it might be endogenous, and you're trying to perhaps have that person not what's the word, act in a way which would be described as compulsive. So I'm just sort of kind of on a bit of a waffle there, a bit of a spiel, but it's, I suppose that's what I think. That's it. OCD is poor metacognition. So, for example, heavily weighting of thoughts as that's it, and thoughts almost being seen as treated as sensory information at times, and there's almost too much weight given to them. It's like, there's a thought. that thought has so much weight that the person is sort of their behavior, and including here other thoughts or consequential thoughts as behavior, are sort of prescribed by that heavily sort of high precision. Does that make any sense?
Yeah, I think you sort of highlighted something really important there, which is that sort of hierarchical balance. So it's not as if precision is just broken too much or too little. The key thing is the balance between the sort of the sensory level and the deeper prior beliefs, and possibly even intermediate levels. And it's the breaking of that balance which I think leads to the kind of psychopathology that you were talking about. And again, you correctly, I think, sort of referred to the notion of false inference as a canonical way, or at least a platonic way of understanding psychopathology. So, what people like me normally say is, if psychology is all about perceptual inference and active inference, panning as inference, then it follows that psychopathology, or pathology of psychology, has to be some kind of false inference. And of course, things like hallucinations and delusions are poster childs of this. So, and I'm talking about false inference, in the way that you would learn about it in Statistics 101, type 1 errors, inferring something is there when it's not, for example, hallucinations and delusions, or type 2 errors, inferring something is not there when it is, for example, neglect syndromes, hysterical syndromes, dissociative syndromes. So much of this kind of false inference really does rest upon getting those precision estimators right. So one way you could describe to your students is, if I had to apply this t-test to these data, and some mischievous elf had got into my software package and completely ruined the estimation of the precision, namely the 1 over the standard error, so that my t-statistics were sort of an order of magnitude too big or too small. Imagine the kinds of mistakes I would get when I was trying to make inferences about what these data were telling me. So, this is a really pernicious, if you like, mathematical pathology, getting the precision wrong, getting the error variances wrong, at any level in a hierarchical model, say within between subject variability, and analysis of variance models, can have devastating effects on your inference. And you've listed a number of them. OCD. I think OCD with lots of behavior, that's really interesting. There was a very interesting Ernst Strungman forum a few years ago, drilling down on that, and I do remember the story ultimately was really seeking for evidence that this behavior had sated or resolved some uncertainty, and yet that evidence not being available. And I think, if I remember correctly, that the best explanation was that you would normally expect the evidence that I've done that, it's all okay, my hands are washed, I've turned that doorknob, from your own body. But if you don't get that evidence, or its precision hasn't been suitably afforded that evidence from your interoceptive signals, then you're left saying, I thought that this behavior would take away all of these feelings, and it didn't. And I therefore have to keep on repeating it in the search of evidence that I've actually eluded this anxious state. And that, I think, could be distinguished between what you were referring to about intrusive thoughts, which I think are much easier to think of in terms of getting stuck in a rut. Remember, we were talking before about these ruts going around in circles as the landscape is changing continuously. So you've got stuck in a circuit, a trail of thoughts that you cannot escape. And how would you ever escape them? Well, you probably need help. You need help either pharmacologically or through therapeutic or cognitive behavior therapy, to flatten that landscape, to allow you to escape from that particular rut. And that picture you were painting, I think, is absolutely right, because the depth of that rut is just determined by the precision of your beliefs. But in this instance, beliefs about the narratives of thought and the trains of thought that are probably a long way away from the sensorium. or perhaps not in terms of internal speech, but at least they're going to be at higher levels in a hierarchy. So in this instance, you would really want to reduce the precision and flatten that landscape at a higher level of narrative and thinking and trains and trains of thought to allow you to break that vicious circle, as it were.
Yes, yeah. And now I suppose I mentioned in the email, and I imagine other people have started to think about this. I mean, off the top of my head, I'm pretty sure I've done 2 searches and I couldn't find any sort of like a paper which has thoroughly explored this, unless if you have, please correct me. But a sort of a predictive processing informed, or a predictive processing account of psychological therapies as a sort of a meta framework. And the reason I say this is I'm working in psychology and mental health at the moment, and I started several months ago, and I've been struck. I mean, I'd obviously I was acquainted with the different schools of sort of modalities of psychological therapies through my studying and just in my own interest. But when you're actually starting to kind of use them and utilize them, it can become a bit confusing at times. You know, you're drawing on these different accounts. You know, you've got sort of the kind of psychodynamic, psychoanalysis, CBT, ACT, these many more. And, you know, it can at times be a bit confusing because they use sort of different language, and they, I suppose, approach things from different perspectives. But really, I suppose, when you really scrutinize them, there are slight differences, but I think when you look at them through the lens of predictive processing, they are approximating the same thing, which is updating priors. However, they are doing it through different means. So, for example, psychoanalysis would be the kind of the sort of exposition of someone's priors or unconscious priors, which perhaps they are not able to, without help, see. That happens through like transference, whereby the person, you know, is sort of bringing forward their priors into the room and maybe not able to actually see this. It's only when they are sort of exposed back to them or relayed to them, they can see them, and then it's like, oh wow, right, there are my sort of priors. If we think of ACT, acceptance and commitment therapy, you know, that's a kind of slightly different, but in the sense it's updating perhaps priors by flattening the landscape or at least one aspect of it, which is it centers around psychological flexibility. They use this thing called the hexaflex, but a lot of it is this flattening of the canal through cognitive diffusion, sort of mindfulness and things like this. And then CBT is, I suppose it would appear, would be almost, and this comes back to the kind of Chris, when we talk about Chris Frith, in terms of how our priors, we sort of provision each other with priors at times. And CBT allows others to have a kind of, you almost offer people perhaps an alternative prior, a kind of, and in doing that, maybe their extant priors are relaxed somehow.
Yes, no, all great examples. And before, I should just say, so Chris and I have been so he joined me when I moved from psychiatry to brain imaging,
Right.
brain mapping in schizophrenia. So we've been long-term friends and
yes,
colleagues.
I've seen you've written, I'm pretty sure you wrote papers together in the 90s, right?
Oh yeah. Probably among my very first papers, yeah. But yeah, those are great examples, and especially this notion of, I think, therapy being able to offer you a greater portfolio or repertoire of ways of coping. And just being able to do that basically means you have to suspend your precise prior beliefs that this is how I cope. So you need to be able to relax your prior beliefs about your plans and your narratives and the paths that you commit to in terms of how you're going to act and how to behave. And I think it's very useful a picture to have in mind of basically flattening the landscape of ways forward in life, or indeed ways forward in any dynamic interaction, just by creating equally plausible options by reducing the precision of the normal one. So I think that that's very important as a picture of what certain kinds of therapies have to offer in flattening the landscape, not by directly changing neurochemically the precision, but just by introducing other options, other values, other ways forward. The other sort of perspective, I think, that's understanding of the mechanics of psychopathology brings to the table is the potential importance of being able to mentalize your precision control. So a lot of these attentional-like processes are subpersonal. And I'll give you two examples that are fundamental to sort of our fluent engagement with the world. The first is saccadic suppression, and this is the phenomena where you attenuate the precision of visual prediction errors during eye movements. So if you look at this, my finger, and then jump with a saccadic eye movement to that finger, you don't actually see the optic flow induced during the eye movement. And this is a very this is an impenetrable kind of precision control, very, very fast, within about 50 milliseconds. So the brain knows that when my eye is moving, so many degrees per second, there's going to be very imprecise visual information because everything's moving around. So I attenuate it, I decrease the precision. And that is, I think, an important example of precision control in the sense of enabling action. So the ability to do sensory attenuation, the brain's ability to attenuate evidence that I am not moving, underlies our ability to move. And if I was unable to attenuate the precision of certain prediction errors, say proprioceptive prediction errors, I might not be able to ignore the fact that I'm not moving, and I might have, say, Parkinson's disease.
Yes.
So, this a lot of this precision control and precision weighting is not under volitional control. But if it could be, you may free yourself from certain automatic failures of sensory attenuation of the kind that people like Rick Adams, for example, in his computational anatomy of psychosis paper, was positing for the reason that people with schizophrenia have very blunted mismatched negativities and later have abnormalities of smooth pursuit eye movements. So what I'm trying to get to, and I'm sure I'm exhausting you and the viewers now, there are certain aspects of precision control at lower levels of the sensorimotor hierarchies that importantly include both proprioceptive and interoceptive things. So we're talking about interoceptive accuracy and gut feelings now, and interpreting things like pain and sources of evidence for me being very anxious that are controlled, and that control can sometimes fail in terms of the precision engineering. And equipping people with the ability to become skilled at this kind of attentional deployment, I think, would be a great gift if you wanted to remedy any failures of that sensory attenuation or selective attention. And of course, that now lends you or leads you to things like internal attention states, mindfulness therapy, meditation, and possibly psilocybin assisted approaches that, if you like, relax the deeper prize in favor of giving you some skill over now being able to volitionally mentalize some of your the precision of your sensory prediction errors. And I know this effect has been taken up by some people in psychotherapy, and in particular some people in neuropsychoanalysis, specifically in the context of interoceptive inference and interoceptive predictive processing. The ability to read our own bodies and infer our usually emotional valence state of being by being able to attend to various sources of evidence from our gut feelings. If that goes wrong, that must be awful. So being able to reclaim some volitional control over that would be very important.
Well, that when you say that, immediately comes to mind things like panic disorders, and again, sometimes I do wonder. It's like OCD. I wonder often, are the intrusive thoughts emergent of they're an interpretation of some like interoceptive or proprioceptive prediction error, or rather the prediction error, just a misreading perhaps of what's going on for oneself.
But
Yeah.
certainly panic disorder, I think, would be the perfect example. That, you know, I suddenly sense evidence that I am in a state of physiological arousal. My best hypothesis is I am anxious. That anxiety then redeploys my precision to attend to the modalities, interoceptive modalities, respiration rate, cardiac acceleration, blood pressure, and the like, that would normally be informative sources. And I see, I now am no longer attenuating all of this information. So this information now says, oh, yes, I am anxious. And not only that, but I'm attending to these things. So that means I must be anxious. So you're going to get one of these vicious circles that if you can't, if you like, break, you would ultimately, the brain will actually be both cause and consequence of the interoceptive evidence that I'm in a state of high anxiety, high uncertainty, and high panic.
Yeah, and the other thing before I don't want to forget is my one of my fascinations is dreams, and it was actually when I did my undergraduate, it was my sort of that's what I focused my dissertation on, and it's where I actually became not firstly actually, before that, but really I sort of got into the literature around predictive processing coding and how I became familiar with yourself, Mark Solms, and I think, dreams, again, they've been, particularly psychoanalysis used as Freud said it's the royal road to the unconscious, I believe. And really, when we think of the unconscious as merely priors, and that, dreams, perception, and memories, they are in some sense all the same thing, just, that they are they are priors. It's just the phenomenology, I can't pronounce it, phenomenology differs, say with dreams, because there is no input, there is less sensory information, and also neuroimaging has shown, that other areas of, for example, the prefrontal cortex is pretty much asleep during sleep, particularly REM. So yeah, it's there just seems to be so much room for a predictive processing. I get the sense that going forward, clinical psychology and mental health would really benefit from just having being able to sort of accommodate all of these different schools of thought under the kind of framework of predictive processing and this belief updating. Because I know for myself, it just helps so much. It helps makes sense of what they're all doing, and that they're approximating the same thing, just from slightly, using different approaches, but essentially it's the same thing, updating priors, and it kind of makes me I was going to ask the question, has anyone ever told you that the predictive processing, or even the free energy principle, just by becoming acquainted with it, has anyone ever told you that it's therapeutic in itself?
No, they haven't, but I think that would be a very natural way, I think, to use these kinds of ideas, because you're at its heart, the free energy principle is very, very simple, and the notion of predictive processing is so self-evidently right when you think about it, when you hear it, that it provides a really nice narrative to understand your own sense making, not just the external world, but the sense making in your relationships. But I repeat, in terms of making sense of signals from your own body. And very much like this, I can remember when I was doing training as a psychiatrist and understanding the rationale for certain kinds of cognitive behavior therapy, where you just take the client through the consequences of hyperventilation in terms of displacing certain molecules from receptors and what that might feel like, giving them a very plausible mechanistic story that makes sense to them so they can understand their own sense making, I think can be enormously therapeutic. Just knowing how I work.
Yes, exactly.
Sometimes be in itself, the major therapeutic gift. So you don't have to cure anybody, but just give them an explanation for why they are experiencing their world in this particular way. It can sometimes be in some instances, be the most important aspect of therapeutic intervention.
Yeah, definitely, and I think it's almost like it introduces another kind of, I don't know if you could say, level of, or rather just improves metacognition in a way, just by becoming acquainted with it.
I think yes, self-modeling, yes, understanding your own understanding, yeah, absolutely is metacognition, isn't it?
Yeah, exactly. So I mean, we've covered a lot there, and it's I think we've answered most of my sort of questions, really. I mean, have you got any hopes for, I mean, we say with the free energy principle, is it, I mean, like, for example, is it now, would you say it's like mathematically and stuff, is it almost completed? Is there ongoing, is it always a kind of, are you, for example, yourself or others sort of looking in ways to kind of like fine tune it, or
it's still on a journey. I mean, the principle is out there. You can read about it, but it's it'll take years to fully consolidate using the right kind of maths. I'm an intuitive mathematician, and my understanding of maths is that of a physicist. There are other pure mathematicians who now need to actually go through and do the proper proofs.
okay.
Take years. And it's happening. There are people now, mathematically skilled people, who are starting to sort of work through the underlying maths. And even my kind of mathematical expositions are now starting to reach the peer-reviewed physics literature, but it'll take several years before all of that. And as you say, there's still so much work to be done. We haven't talked about wandering Markov blankets or Markov blankets that move around. We haven't talked about fuzzy Markov blankets. There are so many different things that need to be addressed, that possibly we haven't talked about consciousness. We haven't talked about at what point it ceases to be a tautology or an as if story, and when we actually realize that we are actually engaged in as if inference. Does that mean that we're no longer engaged in as if inferences? There's a relationship to quantum information theoretic formulations and the FEP that is just starting now. So there are so many different sort of frontiers here. I can't speak about most of them. You need to get people like Chris Fields or Maxwell Ramstead or Dalton and his friends, who to talk about these things. But it's certainly just part of a journey, in the same sense that the free energy principle is just a continuation of a long legacy of right-minded ideas that are usually converging upon each other.
Yeah, and you mentioned them at the beginning, but Plato, Kant, Helmholtz, and now all of this, it just feels like, it's like a very natural sort of progression.
Don't forget cybernetics, ideomotor theory.
Oh, right.
Analysis by synthesis.
Right, I have to look into
perceptual
that.
control theory. The list goes on. Everybody, I think, has been heading in the same direction.
And this is where I suppose, when I was sort of wondering about the, this sort of tendency, this sort of to sort of see it as a kind of a mapping of a territory. It's because I suppose, like most people with philosophical oriented sort of thinking, it's like, and like maybe all scientists to an extent, I don't know, or people not even describe themselves in such a way, but wanting to know what lies beyond my Markov blanket, what lies beyond it, and to what degree is my account of it veridical, or at least not maybe not quite veridical, because I suppose it's veridical in the sense that it's pragmatic, or that it's what's the pragmatic, but yeah, and as you said, like, I mean, gosh, yeah, consciousness, there's all sorts of things, like ontology and whatnot, but it's it's fascinating. And
You're just listening for yourself a whole series of podcasts with experts on internalism and externalism, realism, and what am I? I'm a transcendental realist, I think, according to Maxwell Ramstead.
oh, really?
Yeah, so I think I got that right. I'm not absolutely sure, but I mean, there are lots of people who love to talk to you about that. Jacob Howie would be a key person. Maxwell Ramstead would be another key person.
Okay, brilliant.
In niche hypotheses. There are very skilled scientists who are also trained in philosophy who are exactly speaking to these issues as we talk. I am not one of these skilled philosophers, but I do know they exist.
Yeah, you're probably more skilled than you give yourself credit for as a philosopher. I feel like I mean, I know you once referred to you. No, you didn't refer. You said that someone referred to you as was it an intellectual thug or something?
Yes, that was one of the kind of comments that Jerry.
Yeah, I feel like that's unfair. And I mean, and I know it is unfair because, well, in the sense that you're very generous with your time. I'm really grateful for the sort of 2 hours we've had here, and for all the other podcasts that you've done, because it's one thing to have a theory and to be able to read it through papers and stuff, but it's another thing to be able to actually listen to yourself and others as well, but in this instance yourself, really like give time to actually go through it. It's wonderful. It's I'm very much grateful for it, and I know that there are probably countless others.
Well, thank you very much for having me. I really enjoyed talking to you. You've covered so many things and were cheekily introducing some of the hardest concepts as we went along. So that was very impressive. Thank you very much.
All right, well, thanks very much, Karl, and all the best.